Welcome back to the second part of our exploration into one of physics' most profound truths, that the past isn't gone, it still exists right now in the fabric of space-time itself. In Part 1, we discovered how Feynman showed us that time doesn't flow like a river, that all moments exist simultaneously in the block universe, and that particles can actually move backward through time. Now, we're going to dive even deeper into the evidence that surrounds us every single day. If you haven't subscribed to Discover Physics yet, do it right now, so you don't miss any part of this mind-bending journey through the mysteries of reality. Hit that like button if Part 1 already changed how you think about time. And now, let's continue uncovering why the past is still here. Let me give you another example that makes this even clearer. Light itself. You see light from the sun, correct? That light was emitted approximately 8 minutes ago because it takes 8 minutes for light to travel the vast distance from the sun to Earth. So when you look directly at the sun, you're seeing the past. You're seeing what the sun looked like 8 minutes ago, not what it looks like at this precise moment. And when you look at distant stars in the night sky, you're seeing even further into the past. Some stars are thousands of light years away. The light you're seeing right now was emitted thousands of years ago. That star might not even exist anymore in the present, but its light is still reaching you now. Now, here's the crucial thing to understand. That light, that information from the past, it's still real. It's still here in our universe. It's still part of physical reality. The past is encoded in the light traveling through space. It's not gone or destroyed. It's in transit, journeying across the cosmos. And not just light either. Gravitational waves work the exact same way. When two black holes collided billions of years ago, they sent ripples through space-time itself. Those ripples traveled across the universe, and we detected them in 2015 with LIGO. That event from the distant past reached us in the present. The past, in the form of those waves, crossed billions of years to arrive here and now. So the past isn't gone at all. It's embedded in the universe around us. It's in the light reaching us from distant stars. It's in the cosmic microwave background radiation, the afterglow of the Big Bang itself, which we can still detect today. It's in the fossils buried in the ground, in the rings of ancient trees, in the layers of ice in glaciers. Every single part of the universe carries information about its past. The past is written into the present. It's not separate or disconnected. It's part of the continuous structure of space-time. Now, Feynman would push this even further and deeper. He'd say that when you interact with something, when you physically touch a table or see a tree, you're not just interacting with that object in the present moment. You're interacting with its entire history, stretching back. The atoms in that table were forged in stars billions of years ago. Those stars exploded in supernovas, scattering the atoms across space. Those atoms eventually came together to form the Earth, and then the wood, and then the table. Every atom carries that history within it. And when you touch the table, you're touching all of that accumulated history. The past is physically present in the structure of matter itself. Here's another way Feynman thought about it deeply. He was obsessed with the idea that the universe might be deterministic, that the present state of the universe completely determines both the future and the past. If you knew the position and velocity of every particle in the universe right now, you could, in principle, calculate what the universe looked like at any point in the past and what it will look like at any point in the future. The information is all there. It's encoded in the present moment. Quantum mechanics complicates this picture, adds uncertainty and probability, but the basic idea holds. The past isn't erased. It's compressed, encoded, preserved in the structure of the present. Let me tell you something Feynman said that really captures this essence. He once remarked that from the perspective of a photon, a particle of light, no time passes at all. A photon travels at the speed of light, and at the speed of light, time dilation becomes infinite. From the photon's perspective, it's emitted and absorbed in the same instant. It doesn't experience duration. For the photon, the entire journey from a distant star to your eye happens in zero time. Think carefully about what that means. For the photon, there is no past and future as separate categories. There's only one eternal moment, and in that moment, everything that we perceive as separated in time is simultaneous. The star emitting the light traveling through space, you seeing the light, all the same instant from the photon's point of view. Now, obviously, we're not photons ourselves. We experience time flowing. We have memory, causality, a clear sense of before and after. But Feynman's point is that our experience isn't the only valid perspective on reality. The laws of physics describe a universe where time is more flexible, more relative, more interconnected than our intuition suggests. And when you take those laws seriously, when you follow them to their logical conclusions, you find that the past doesn't disappear. It remains as a valid part of spacetime, as real as the present, just located at different coordinates in the four-dimensional structure of the universe. Here's the thing, though, and Feynman would be the first to admit this honestly. This doesn't mean you can change the past. You can't go back and undo what happened. The past is fixed, frozen, unchangeable. Not because it's gone, but because it's already part of the structure. It's like asking if you can change New York while you're physically in Los Angeles. You can't. New York is what it is whether you're there or not. Similarly, yesterday is what it is whether you're there or not. The block universe view says all moments are equally real, but it also says they're all fixed. The past exists, but you can't alter it. Time travel in the sense of going back and changing things creates paradoxes that physics seems to forbid absolutely. But, and this is crucial, the past still affects the present profoundly. It's still causally connected to now. Everything that happened before led inevitably to this moment. The past is the foundation on which the present is built, and in that sense, it's not gone at all. It's more present than ever. Every memory you have, every scar on your body, every skill you've learned, every person you've met, all of that is the past persisting in the present moment. You are, in a very real sense, a living record of your past. The atoms in your body are remnants of dead stars. The patterns in your brain are shaped by experiences you had years ago. The past lives in you. It's not behind you. It's inside you. Now, let me address something that might be bothering you. If the past still exists, why can't we access it? Why can't we go back? Why does it feel gone, even though physics says it's still there? And the answer comes back to entropy, to the arrow of time, to the statistical nature of why we experience time the way we do. Imagine a movie playing forward normally. You see events unfolding, things happening in order. Now play the movie backward in reverse. You see the same events, but in reverse. The physics of individual particles doesn't care which direction is which. But when you have many particles, when you have macroscopic objects like people and planets, entropy gives you a direction. Things break into pieces. They don't spontaneously unbreak. Eggs shatter when dropped. They don't spontaneously reassemble. And our consciousness, our memory, is tied directly to this entropy increase. We remember the past because low entropy states naturally evolve into high entropy states. And that evolution creates records, creates memory traces, creates the feeling of time passing. But here's the kicker. From the block universe perspective, memory isn't about the past being gone and then recovered. Memory is about different time slices of you having access to information from other time slices. Your brain right now contains patterns that were created by your brain 5 years ago. That's a physical connection across time. It's not mysterious. It's just information being preserved in a structure that persists through time. And that persistence is possible because the past and present are part of the same continuous spacetime. If the past were truly gone, if it didn't exist anywhere, there would be nothing to remember. The fact that you can remember the past is evidence that it's still there, still part of the structure. Now, Feynman loved thought experiments. He loved taking ideas to their extremes to see what they revealed. So let's do one. Imagine the universe is like a film reel. Every frame is a moment in time. When you watch the film, you see one frame after another, and you perceive motion, change, a story unfolding. But the film reel itself, the physical object, contains all the frames simultaneously. They all exist at once on the reel. You watching the film corresponds to you experiencing time. But the film doesn't care about your experience. All the frames are equally part of the film. The universe, according to this view, is like that film reel. All moments exist simultaneously in the structure. We experience them sequentially, frame by frame, but they're all there. The past frames aren't gone. They're still on the reel. We just can't rewind and watch them again because our consciousness only moves forward through the frames. Okay, here's another mind-bending thing Feynman understood. Quantum mechanics, the theory governing the behavior of particles at the smallest scales, has this weird feature. Particles don't have definite properties until they're measured. Before measurement, an electron doesn't have a definite position or velocity. It exists in a superposition, a combination of all possible states simultaneously. And when you measure it, the superposition collapses and you get one definite outcome. Now, here's the strange part. The act of measuring affects not just the present, but also the past. There's an experiment called the delayed choice experiment. You send a photon through a setup where it can take two different paths, but you don't decide how to measure it until after the photon has already committed to a path. And what you find is that your choice of measurement in the present seems to determine which path the photon took in the past. It's as if the present reaches back and affects the past. Now, this doesn't mean you can send messages to the past or change history. The mathematics prevents that. But it does mean that the relationship between past and present is more entangled than we thought. The past isn't a fixed, independent thing that's completely separate from the present. The present helps determine what the past was. And this makes sense in the block universe view. If all of time is part of one structure, then correlations can exist across time, not just across space. The past and present are connected, not just causally, but in deeper ways revealed by quantum mechanics. Feynman worked extensively on quantum electrodynamics, the theory of how light and matter interact. And in QED, the fundamental entities are events in spacetime. An electron here emits a photon. The photon travels. Another electron there absorbs the photon. Each of these events is a point in spacetime, and the theory calculates the probability of different sequences of events. But notice what's happening. The theory treats time and space on equal footing. Events are located in space-time, not separately in space and in time. The past events, the present events, the future events, they're all part of the same calculation. They all contribute. The past isn't gone from the equations. It's right there interacting with the present and future through the rules of quantum mechanics. Here's something beautiful. Feynman didn't just accept these strange ideas. He used them. He turned them into tools. His diagrams, his path integral formulation, his whole approach to quantum mechanics was based on taking the idea of particles exploring all possible paths through space-time, including backward in time, and using that to make predictions. And those predictions are the most accurate in all of science. Quantum electrodynamics predicts the magnetic moment of the electron to 11 decimal places, and it matches experiments. That's not a coincidence. It's because the theory is capturing something true about reality. And part of that truth is that the past isn't gone. It's part of the structure that determines what happens. Now, you might be wondering, okay, fine. The past exists in some abstract sense, but so what? What does this mean for me? How does this change anything? And that's a fair question. On a practical level, it doesn't change much. You still can't go back and fix your mistakes. You still have to live with the consequences of your choices. You still age, grow, and eventually die. But on a deeper level, it changes everything. It changes how you think about your life, your identity, your place in the universe. If the past still exists, then every moment you've ever lived is still real. It's still part of the structure of space-time. Your childhood, your first love, your greatest triumphs, your worst failures, they're all still there, not just as memories, but as actual events, actual parts of the universe. You're not leaving them behind. You're carrying them with you, in a sense, because you're a four-dimensional object stretched across time, and every moment is part of that object. The universe is not what you thought it was. Time is not what you thought it was. The past is not gone. And once you understand that, once you really grasp it, you can't unsee it. You see the universe for what it is, a four-dimensional structure where every moment is real, every event is eternal, and nothing is ever truly lost. That's what Feynman saw. That's what physics reveals. And that's the truth about time.